During quarantine, my family and I have played a lot of games, as I'm sure a lot of you have. One of our favorite games is Mario Party. And when we're playing Mario Party, there are a lot of different characters and there are a lot of different dice options according to the different characters. And if you ever played Mario Party, it's just like a board game where you roll to move different places, but certain spots in the game board are more valuable than others, so you want to increase your chances as much as possible to land on those spaces. So you got to know a little bit about the probability of the dice rolls, and sometimes you can pick up allies along the way, and you get to choose from, sometimes up to 5 different types of blocks if you have collected 4 allies. So if you need a certain number roll to get to a star or a mushroom space or a lucky space, or to try to avoid a bad luck space, you want to understand the probabilities of the dice that you have so you can give yourself the best chance of landing on that block. And that's what today's lesson is about simple probabilities. Thinking about the probability of rolling a certain number on a die, or pulling a card out of a deck, and then we're going to eventually move into some more complex probabilities called compound probabilities, meaning finding, when you have 2 different events going on. So maybe rolling 2 dice or 3 dice, or rolling a die and choosing a card. But today we're keeping it simple, looking at simple probability, and we're going to start off with looking at your assignments here. So some vocabulary to look at when talking about probability is, first of all, sample space. So when we talk about sample space, we're talking about what is everything that could happen. What are all possible outcomes? And they actually kind of tell you what the sample space is in the question right here. It says, give the sample space describing all possible outcomes. So in this case, we're rolling a number cube with bases labeled 1 through 6, and we all know a number cube at this point is just the mathematical way of saying a die. So when we're looking at this particular one, everything that you can think of that could happen on a die is you could roll a 1, you could roll a 2, you could roll a 3, a 4, a 5, or a 6. All right, so that would be the sample space of rolling a standard number cube. Then it asks, what about the event of rolling from 2 to 4? So now you have to think, okay, out of that sample space, what numbers are from 2 to 4? And it's 2, 3, and 4. All right, so this is the basics of simple probability here. All right. Let's move on to the next type of question we're talking about here. So now we have a bag with marbles. There are different colored marbles. There's some gray marbles, some black marbles, some white marbles. And now we're actually looking at what is the probability. And in order to find the probability, what we have to do is look at what is the sample space, like how many items are there in the sample space. And in this case, you could get 4 black marbles, you could get 4 gray marbles, you could get 2 white marbles, but altogether there are 10 marbles. All right, so that is basically the total number of outcomes. And that's what you have to divide by when you're trying to find probability. And then, like we talked about, the event. So in this case, the event is white. So if the event is drawing a white marble, we have to think of the number of ways to get the event. My words ran together there. And that's how we're going to find probability. In this case, it's 2. So there are 2 white marbles out of 10 total marbles, and that can simplify to 1/10. So that is our simple, I said 1/10, I meant 1/5. That is our simple probability. And it does say make sure that we write our fraction in simplest form. Let's take a look at another example. So in an aquarium, there are 10 large fish and 5 small fish. Half the large fish are red. One fish is selected at random. Find the probability that it is a large red fish. So now what we have to think about here is, once again, what are the total number of outcomes? And in this case, the total number of outcomes are 15. All right, so there are 15 total fish. And then the desired event is, how about a large and red fish? All right, so we have to think about how many large red fish are there. Well, we know that there are 10 large fish, and we know that half of these large fish are red, which is going to give us 5. All right, so once again, to find simple probability, we're looking at how many ways can the event that we're looking for happen, and in this case it's 5, divided by how many total things could happen. In this case there are 15 total fish, so we're looking at 5 out of 15, and that simplifies to 1/3. So I'll go ahead and put 1/3 in. And let's do one more here. All right. So if anybody has ever played cards, any kind of poker game, my family and I, we like to play something called Pedro or Double Cinch. It's what our family does when we get together and with friends and everything. In fact, in about 8 minutes from now, my family has a virtual Pedro tournament going on that we play on our phones. We downloaded some apps. So we have to know the deck of cards very well to know the probabilities of things. All right, so if you're not familiar with the standard deck of cards, there are 52 total cards in the deck, and then there are 4 suits. There are hearts, there are diamonds, spades, and clubs. And every suit has the same types of cards. The A stands for ace, and then there's 2 through 10, and then there are something called face cards, which are jacks, queens, and kings. Because if you looked at a deck of cards, they literally have a face on them. They are like cartoon characters, if you might say. All right, so with a deck of cards, if you are drawing from a standard deck of cards, the sample space, or the total number of outcomes, is always going to be 52. All right, so we're looking at 52. Now this is a nice visual that they give us. So when they say, what is the probability that the card drawn is a face card? Well, we look at all the face cards that we have here. All right, we have 12 of them. I'm just doing some quick multiplication. There are 3 different face cards in each suit, 4 suits. So we have 12 out of 52, and we can obviously simplify this. We can divide both of these by 2. So that would give us 6 out of 26. And we can divide each of those by 2 again. So we could have 3 out of 13. All right. And if you might be thinking, well, Mr. Maz, that makes a lot of sense because every suit has 13 total cards. And out of those 13 cards, 3 of them are face cards. Then you would be right. That's another way to be thinking about it, because if every suit has 3 out of 13, then that fraction is always going to simplify to just that. So A is going to be 3 out of 13. So we'll go ahead and put that in. The next one, what's the probability that the card drawn is going to be diamond? Now there's 2 ways to think about this. One, there are 4 total suits. And one of those suits is diamonds. So we can just say our answer is 1/4. If you want to look at the whole entire deck of cards, we can think of, okay, there are 52 total cards. And out of those 52, 13 of them are diamonds here. So we could do 13 out of 52, which they both can be divided by 13 and give us that 1/4 that we're talking about. And then the last one here, what's the probability that the card drawn is a face card or a diamond? So now we have to think about how many cards are there that are face cards or diamonds, and you have to be careful not to double count here. All right, and I'll show you what I mean by that. All right, so you might think, okay, there are face cards, so there are 12 total face cards in the deck. And then there are also 13 diamonds. And don't make the mistake of saying, okay, well that's 25 total cards, because the Jack, Queen, and King of Diamonds were counted twice in that situation. So we have to make sure that we don't do that. So what you could do is, okay, well, we can minus those 3 cards of overlap. So there are 22 cards that are either a face card or a diamond card, or you can really just count. All right, so we know that we have 12 of these, and then 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 total cards. And that, once again, is out of 52 total. So 22 out of 52. Need to simplify this again. I'm going to divide both of these by 2 and get 11 out of 26. So let's go ahead and put that answer. 11 out of 26. And we are correct there. All right, so as I have been doing recently, just showing you different questions from your assignments. So this assignment is obviously on Alex. It is called Probability of Simple Events. All right, so there's a couple things about sample spaces, events, and then finding those simple probabilities. In this case, you'll see that there are 15 total questions. This should be kind of a familiar thing. It's kind of a relatively easy thing, so I thought that you could very simply handle 15 questions. Pun intended there. Good luck, and if you need any assistance, make sure that you Zoom me during class time or office hours, or you can shoot me an email if it's something that we can figure out quickly.